In this lesson, we are going to look at a new sequence different from arithmetic sequence, and let's see how this sequence is identified and how the nth term and sum of terms are found out. So I'm starting with a question where the annual salary of a person is $49,000 and the salary is expected to increase 5% each year. Okay, so remember, now this is not by the same amount. 5% will be 5% of that salary, right? So if today my salary is 100 and 5% of that is $5, next year my increment has to be 5% of 105 and not 100. So it's not like simple interest now, it is changing differently. I want you to pay attention to that it's not the same difference. So slope may not be the same. So the first thing they're asking is, how much will the salary be after 4 years? So like the fourth term, the end of the 4th year, so therefore the 5th term. And also if you try to save half your salary and at a for some interest, then how much will be the total savings if you are receiving a job, and after 4 years how much will you be able to save? So both those questions are being asked. So let's try to understand what is the way it is going to be solved. And the question is, so your first term, which means in the first year you have 49,000. What will happen to your salary in the second year? It is 5% of this, so it will be 49,000 plus 49,000 times 5%. So the other way I can say is 49,000 times 1.05. What will happen in the third year? Well, it will be 1.05 of what was the salary at the end of 2 years, or the other way is 1.05 square of the first term. What will happen in the fourth year? At the beginning of the 4th year, okay? The beginning of the 4th year is 1.50 times A3, which means 1.50 times 1.05 square of A1. So it's 1.05 raised to 3 of A1. Okay. What will happen at the end of 4 years, which means in the beginning of the 5th year? That's what they're asking. At the end of 4 years, what will the salary be? So now logic says 1.40 times 4, right? Because 4 more years have passed after the first salary. So that was much should be your salary. So your A5 should be 49,000 times 1.05 raised to 4. Yeah, you can find out the answer on the calculator, but I hope you understand what is happening here is it is getting multiplied by the same amount. So if I had to find the answer in the nth year, at the end of n years rather, or the beginning of the n plus 1th year, then I will have to do this, or I'll have to do n plus 1 minus 1. So how many ever years, that much minus 1 is the number of times I have to multiply that ratio. So what is the difference here from the arithmetic ratio to this? There is a common ratio rather than a common difference. It's not getting added, it's getting multiplied. Those are the differences that you are seeing. So that's the expected salary that you will be doing. Now if I'm earning the same amount of interest, say 5% interest only I'm earning, and I'm saving half of my salary every year, then how much will my total money be at the end of 4 years? If that's what I want to find out, then let me show you. So my first year is A1, the second year is A1 times R. Of course here A1 is not 49,000, okay, it will be half of 49,000. That is how much I'm saving. What is A1 into R? I'm earning 5% interest. So at the end of the first year, I will get A1 into R, the interest earned for that, and plus 49,000 that half of 49,000 that I'm saving. Then I will get 2 times interest in the third year plus the 49,000 that I'll add, plus I'll continue getting this for all the years that I will save. So this is not just finding the nth term, but this is finding the sum of all the savings that I have. So because I'm saving half money every year, plus I'm getting interest for the previous half money that I'm getting. So at the end of first year, I will only have half of 49,000. End of first year. At the end of second year, I will save half of 49,000 in the second year, plus I would have earned interest of 1.05 on the half of 49,000 for the first year. Same way, if I continue, how much will I be doing? So I'll have, at the end of 4 years, in the fourth year I would have saved this. Whatever amount I saved in the third year, I would have earned interest for 1 year. Whatever amount I saved in the second year, I would have earned interest for 2 years. And whatever money I saved in the first year, I would have earned interest for 3 years, and so on. So that is the meaning of sum of terms in a geometric sequence. Sum of terms. And when I do sum of terms, it's also called geometric series. Why is it geometric? Because there is a common ratio. Why is it sum? Because every year I'm saving half of 49,000 and I'm earning interest for all the previous amounts. And the formula for this is A times r raised to n minus 1 upon r minus 1, where A is the first term and r is the common ratio. So in this case, A is every year the first year I'm saving is for half of 49,000. In fact, that is for every year. And my R is 1.05. N is for 4 years I'm doing this, divided by 1.05 minus 1. What if R is less than 1? Well, it will just reverse. The numerator will be negative, the denominator will be negative, it will take care of itself. So don't worry if R is greater than 1 or less than 1. The formula remains the same. This is given in your formula booklet, and remember the answer will be rounded to 2 decimal places because it's money. Correct? And that's how we work with geometric sequence and series. Sequence means finding the nth term and series is finding the sum of terms. Let me give you one more example and then write down summarize the formulae. So say for example, I have a situation, and this is for maybe biology or chemistry students. I am looking at the effectiveness of an antibiotic which is working against some bacteria in my body. Okay, so the certain bacteria is introduced, and then the number of bacteria is monitored, how they grow, and then the antibiotic is given, and then we are seeing how they reduce. Correct? So the bacteria that are introduced in my body double every 4 hours. Okay, so that's the ratio. How many bacteria will there be after 24 hours? For every 4 hours. So first of all, in 24 hours, how many 4 hours are there? 6. Correct? So it is doubling every 4 hours. So 6 times it will double. If I start with 19 bacteria, so the first term is 19. So at the end of the first 4 hours, what will happen? 19 will double. At the end of the second 4 hours, what will happen? Double of double. At the end of the next 4 hours, what will happen? Double of double of double. So at the end of the 6th 4 hours, what will happen to the nth term? 19 times 2 raised to 6. This is my nth term, where 19 is my first term and 2 is my common ratio. Why did I do raised to 6? Because there are 6 4 hours, right? That's why. Now the antibiotic is applied or given or whatever. Then it is found that it kills 1/3 every 2 hours. So how many will be left after 24 hours? So after it grew, right? After growing, so I have already reached to this 19 into 10 2 raised to 6. That is my value now at the end of 24 hours. After that growth, now I have applied antibiotic. So I'll start with that initial value. And then what is happening now? The ratio is 1/3 for every 2 hours. And then what will happen to the bacteria? So now I know that my first term is how much? 19 times 2 raised to 6, which is 1216 bacteria. And starting with this bacteria, what is my formula? My formula is A times common ratio raised to n minus 1. Because each time I multiply by the number. That's how geometric sequence works. It's adding the common difference in case of arithmetic. It is multiplying by the common ratio in case of geometric. So 1216 is multiplied by how much? It's getting reduced by 1/3 is getting killed. So what is left? 2/3. See, either you do this way, it is getting reduced by 1/3, or 2/3 is what is it, 2/3 remains. What, both are the same. How many hours do I have to, how many terms should I take? Only 12, because for every 2 hours 1/3. In 24 hours, how many 2 hours will be there? 12. So I'm looking at only 12 terms. So that's my, so 1216 times 2/3 raised to 12 is what is happening. This time, remember, see, the amount is decreasing. Earlier, bacteria were growing. Every 4 hours it was doubling. Now every 2 hours, 2/3 is getting reduced. So what will be the amount after that? You will multiply with your calculator and round off to the nearest integer, because they are asking you number of bacteria. So if you do 1216 times 2/3 raised to 12, I'm getting 9.37. Now if they are asking the total number of bacteria that will remain, you will obviously round off. So you can write it off as 9.37 and then say nearly 9 bacteria are remaining at the end of. So in context of this problem, it was necessary to round off to an integer. So also having that judgment that whether I should round off to 2 decimal places or to an integer is also something that application and interpretation course expects you to know, and accordingly report the answer. So sometimes they say report the answer in context of the problem, which means they're hinting towards the rounding or the number of significant figures that you should use. So do you see here also the idea of significant figures is appearing? So let me summarize. In case of a geometric sequence, first is the ratio remains constant, and here the nth term is given by the first term times common ratio raised to n minus 1, where n is the number of terms, and the sum of terms is given by a times r raised to n minus 1 upon r minus 1. Those who want to know the derivation of, I'll give you a simple version of the derivation. So Sn is a1 plus a1r plus a1r square plus a1r cube and so on. Okay, plus a1r raised to n. Multiply by r, a1r square plus a1r raised to, this is n minus 1 and this is n. Subtract the first equation from the second, and you realize some of the terms get cancelled and only the last term and the first term stay. So Sn is equal to a1r raised to n minus 1 upon r minus 1. You don't need to know the derivation, but those who are curious where I got it from, I'm just giving you the way the derivation came into existence.